Uh, Hello, good morning, good afternoon, good evening, everyone, depending on where you are joining us from. I hope you can hear me well. So my name is Gode. I'm part of the ECOP training and mentoring team, tax team, and I'll be your moderator for today. So just a quick introduction. So the ECOP program is the early career, the UN Ocean Decade Early Careers Ocean program. So basically, it's for capacity building and uh, outreach, training, and mentoring for early career ocean professionals around the world. And we have several uh, regional and country nodes. So there are many countries that we have ECOP, Netherlands, ECOP, India, ECOP, Ghana, several countries from across the world. And then a huge membership database. So you can imagine the ocean, and so many people love the ocean or are studying the ocean, are working with the ocean. So for the early career ocean professionals across the world, this is the program, the right program for you to follow, to engage, and to do something with. And so today we have our usual monthly webinar series, and this happens to be episode 31. So we've done so many, about 30 different webinars in the past, and today, so we have a new one, and then, so it's basically, we have Dr. Chen and Dr. Sian here with us today, and then we'll be very happy to learn about how to bridge science and societal needs with public products. So I would give them the chance to introduce themselves for you. So Kian, can you please go ahead?
Yeah, thank you, Gaudi. Can you hear me?
Yes.
Okay. And good afternoon from China. My name is Tian Zhao, and I work for the OSF program. OSF stands for Ocean to Climate Seamless Forecasting System. It is an endorsed Ocean Decade program focusing on promoting seamless forecasting and to provide public products to the globe. So I'm very happy today to join this webinar, and I will be introducing our program, the basic information of our program to everyone. Thank you again for joining this webinar.
Yes, please. I think you can go ahead with the first presentation if you are starting, or.
Okay, thank you, Gaudi. And can everyone see my slides?
Yes, yes, please. We see it now.
Okay, I'll go ahead. So my introduction today will consist of 4 parts. So first of all, what is OSF? This all starts from numerical models. Numerical models usually represent the comprehensive level of our scientific understanding of the ocean. However, since the first ocean general circulation model developed by the US in 1967, there remains huge common biases in ocean, typhoon, and climate models for a very long time, for decades. And this actually caused the knowledge gap between weather forecasting and climate prediction. We can see from the figure on the left that we have a good ability to make weather forecast in the upcoming, for example, 1 week. And our ability to make seasonal forecast is also fair. However, there's a huge gap between the blue line and the purple line. This is what we call gap between weather forecasting and climate prediction. And seeing this gap, we would like to narrow it and even close it. So we propose the Ocean to Climate Seamless Forecasting System program. It was endorsed in June 2022 by IOC UNESCO as an UN Ocean. As a program, we mainly focus on tackling 3 major ocean decade challenges. The first one is Challenge 5, unlock ocean-based solutions to climate change. And then we would like to increase community resilience to ocean hazards. And then also, we would like to expand the global ocean observing system. This, in the end, leads to a predictive ocean where society understands and can respond to changing ocean conditions. So the vision of our OSF program is to advance ocean climate nexus understanding and to provide high-quality seamless prediction. Our ultimate goal is to build a system that will provide ocean climate seamless forecasting in a timescale from hours to years and in a spatial scale from kilometers to global. In order to achieve this goal, we now have 11 projects under our program. The first 2 focus on ocean observation, including in-situ observation and satellite observation. They are led by scientists from China, from Brazil, and from France. The third project focus on theory advancement. We have renowned scientists from the USA, from Australia, and from Sweden to make advancements in air-sea ice process for model development. Then, with these theoretical breakthroughs, we would like to develop new generation models. And these projects is led by scientists from Germany, UK, and China. After all these efforts, we would the ultimate goal for us is to use model for application for society needs. So we are developing multi-hazard early warning system towards a smart ocean. And then we would like to demonstrate and apply them globally and in specific regions. Of course, we also focus on communication coordination and especially capacity development. These projects are this project is led by 2 very excellent early career scientists. Project A to project the UN Ocean Decade, focusing on different regions, for example, Africa and Northwest Pacific, and also the Arctic. And then on different themes, for example, coral reef health. So they together build up our network of observation, theoretical advancement, model development, application, and regional focuses. With these 11 projects, we can basically cover the understanding of the ocean in the ocean, from the sky and on the land. Currently, the OS program has a very large global network, and from 52 countries. We have 78 institutes partners and 5 international organization partners. And the primary focus of OSF is to provide public products. First of all, is for observation. So if we all know that if we would like to understand the ocean better, we have to have more data from the ocean. This make buoy an inevitable demand and for ocean observation. However, buoys are usually very expensive and very not very easy to deploy of ocean observation. That's why we need low-cost, wide distribution, real-time communication drifting buoys. And what OSF provides is a smart, easy to deploy, and most importantly, low-cost, new generation global navigation satellite system buoy, which was launched in 2023. And now we are sharing this product with our partners. The cost of this buoy is roughly 4% of conventional buoys. And the second product that we provide is the BV series, the non-breaking surface wave induced vertical mixing series. Narrow of the mixed layer depth was reduced from 10.8 meters to 1.5 meters. This is an about 86% improvement in simulation accuracy. And this series has already been recommended by the IOC as a best recommendation for model. And based on all our theoretical achievements, we launched the Ocean and Climate Early Warning Universal System, the Oceanias system, in 2024. It is developed on top of the ocean forecasting system, and we provide 3 different subsystems for public use. One is search and rescue, and the other is oil spill system, and then we have the early warning for coral reef bleaching. In the future, we are going to add the typhoon system and climate prediction system to the Oceanias. You can see the different outlook of the subsystems. Currently, we are discussing with partners from Ghana, from Brazil, from Togo, and from Bangladesh to make localized products based on Oceanias. And the next product is the COAST Toolkit, which was just launched this year. This is one of our most important products inputs to the ocean decade. Dr. Jie-Chen Zhao will show you more detail about this toolkit in the next presentation. So I will just skip this part and leave more space for Dr. Zhao. Apart from global projects, we also make some localization efforts. For example, our ocean forecasting system was ported successfully onto the website of LC Africa. So every African scientist, they can just um, browse the LC Africa website, and they can find the OFS system with data, with forecasting data for African region. And also we have localized in Southeast Asia. This system is called Malaysia Marine Focus System, which was developed based on our ocean forecasting system. And it is now the national operational forecasting system of Malaysia, and it provides 5-day prediction results of ocean currents, wave heights, and surface temperature in this region. The first one would be our satellite event at the 2024 Ocean Decade Conference. During this conference, we invited several world-renowned experts to be our speakers and to discuss ocean-based solutions for climate change, with Africa as an example. And this was a very successful event with the participation of more than 40 scientists and early career researchers. And this activity is also helped us build a larger global network. And in 2024, we also organized a parallel session during the Ocean Development Forum in Qingdao. And it is during this parallel session, stakeholders from different countries, scientists, politicians, and industry representatives, they agreed that a strong international cooperation platform is needed to mobilize global sources and enable seamless forecasting. This calls for establishing an effective international platform for ocean and climate forecasting and disaster risk reduction, one that provides cross-regional, multi-level services to provide global efforts to blue disaster preparedness and resilience. And this is what OSF always aims to. We would like to finally serve for society's needs. And in this year, we also joined the LC Indio first meeting. And during this meeting, we proposed the establishment of a comprehensive disaster risk reduction system covering the wider Indian Ocean region. Also, we participated in the Indian Ocean Conference this year in Nice, in France. And we launching coastal, and also we have another some to highlight is our cooperation with OAAD, which is the Organization of African Academic Doctors. So this represents our focus on capacity development. OAAD is one of the largest academic doctor organizations in Africa. And so with our cooperation with OAD, we have made a lot of collaboration with scientists, especially young scientists from Africa. We provide them with platform for international exchanges and for capacity development. And more importantly, they also feedback us with some regional specific needs from their countries. And so this comes to our support for early career ocean professionals. So we, with our focus on early career scientists, we have actually made a lot of efforts. And the first one is our international intern program. We are always committed to our role in empowering young ocean professionals. So the OSF International Internship Program is open all year round to young scientists worldwide with background in computer, oceanography, and atmospheric science. Selected candidates they will be provided with travel, accommodation, and daily support, and they can join OSF as our project officer, and they will carry out some joint research and some joint application work with our scientists. Until now, we have already hosted two interns, one from Togo in Africa and another from Brazil in South America. And we also provide training opportunities together with our partner of the ODC Center of IOC Westpac. The ODC Center has organized 14 training courses during the past more than 10 years. So basically, every year during the summer, they will organize a thematic training program. During the past, during 2011 to 2024, a total of 1,500 applicants from 70 countries were received, and 750 trainees from 55 countries were selected and trained in Qingdao. This year, the ODC training just closed last month. It focused on the application of ocean focus system, and we hosted 35 trainees from 18 countries. Our scientists from OSF, from DCC, OCC, and also from our global network, they provide excellent courses and hand-on exercise opportunities. For the upcoming 3 years, we have some training plans. For example, for 2026, we will focus on ocean dynamics and ocean models. And in 2027, our focus will be climate dynamics and air-sea interactions. And in 2028, the course will be on regional coupled focus system. So if you are interested in getting trainings on these topics, you can always keep an eye on us. And also we organize various workshops, but in both on-site and online. For example, in this September, we organized an on-site workshop focusing on academic writing and international collaboration for early career ocean scientists. We invited scientists from Italy, from Malaysia, and from Pakistan and from China to give reports on academic writing, scientific presentation, and some early career scientists to share their experience in international collaboration. And also we have this online webinar today. In the future, there will be more workshops, both on site and online. And lastly, I would like to mention our our big plan for the future. So we are preparing for an international organization, so that our OSF can serve during and beyond the ocean decade. It will be an international academic and non-profit social organization formed by scientific and technological professionals and institutes engaged in marine and climate prediction and forecasting research worldwide. It's the establishing of a low-cost global ocean observation system, advancing of theories, models, and technological innovation, providing high-resolution ocean climate focused products, and on capacity development and ocean literacy activities. Currently, we are in the preparation stage, and we welcome scientists and early career professionals and also other stakeholders worldwide to join us. If you are interested in this area, this research field, please feel free to join us, to reach out and to share your ideas. So that's all of my presentation today. Thank you. Thank you, Gadi.
Hello, yeah. Thank you very much, Sian. That was amazing. And I mean, I agree with having an international platform for ocean forecasting and to help tackle disasters, the ocean disasters. So that was really amazing. We can also now launch the post to as a little break to see where our attendees are joining from, and yeah, just some little questions to get to know our participants. So please, do you see the post? If you see the post.
Yes, I can see.
Sure. Please go ahead and answer the post. Your answers would be highly appreciated. Oh, okay. So far we have 3 answers. 2 are ECOPS. Amazing. We have someone from the academia, NGO, and then the private. Nice. Someone joining from Europe, someone joining from East Africa, and then South America. Great. All right, thank you. Yeah, we can. We have 5 answers, so great. If anyone hasn't answered yet, please go ahead. But otherwise, I can end the polls in 5, 4, 3, 2, and 1. So yeah, I mean, we have more ECOPs here, which is nice. And then most are from the NGO and then the academia. We have someone from the private sector, which is amazing to know. And then East Africa having the most people, amazing. We have someone from Europe, we have West Africa, and then South America, even Oceania. So great. Yeah, 2 people have previously heard of the OSF program. Great. Most people haven't, so I think that is also great to know that it's your first time and it's a great learning opportunity. Thank you very much. So yeah, we can quickly go ahead with the second presentation from Dr. Jason. Please go ahead and introduce yourself and go ahead with your presentation. Thank you very much.
Okay. Thank you, Gordy. And hello, everyone. I have shared my screen. Okay. My topic is today is to introduce a toolkit. The toolkit is called Coastal City Ocean-Based Solution Toolkit for Sustainable Development. My name is Jiechen Zhao. I come from UN Decade Collaborative Center on Ocean Climate Nexus and Coordination. We call it DCC-OCC for short. This toolkit is developed by DCC-OCC and supervised by Professor Fang Liqiao. He is also the director of DCC-OCC. And as Ms. Qian just introduced, this toolkit is also a very important outcome of OSF program. Some information in my presentation is quite similar to Ms. Qian's. So when I introduce, I will skip these slides. Okay, I will introduce my presentation in 4 parts. The first one is what is a toolkit? The toolkit, we developed the toolkit to sorry. We developed the toolkit to dedicated to the goals of Ocean Decade, and the toolkit addresses the challenges of marine and coastal disasters based on ocean solution, and we hope it can serve as a bridge link ocean science with decision makers and users. And this is the interface of the toolkit, and you can find the website in the bottom, and this is a free access website. Everyone can access it freely if you have internet. I hope I encourage everyone to try it. And the toolkit, the COAST toolkit was officially released in the third United Nations Ocean Conference in Nice, France, on 80 string this year, and this finger shows the announcement in the conference. And the reason we developed the toolkit is as we know, the coastal cities are facing huge challenges, especially from the high impact ocean related hazards. For example, the typhoon, the tsunami, the drought, and the flooding. The left finger shows the typhoon and tsunami. Not all the typhoon tsunami, but the famous one in the last 20 years. And if we look at the fingers, the red fingers, you can find the very large number of the natural disasters, and a lot of people deaths or wounded during the disasters, and the economic losses is very huge. And if we look at the foundation, the funding from the government to face the ocean hazards, the funding is much smaller than the economic losses. And the challenges for the sustainable development, we think we have three aspects. The first one is the cost for the ocean observation is very expensive. Because if we carried out the ocean observation, we need to rent a ship, or we use a scientific research vessel. As we know, the scientific research vessel is very expensive. For example, for 3,000 ton size vessel, the cost for 1 day is about 300,000 RMB every day. So the cost is very large. And if we use the satellite to do the observation, the satellite is much more expensive. The second challenge is we lack of the accurate prediction because we lack of the observation. That's challenge one. And we lack of the understanding of the ocean processes. And then we know less about the, we don't have a good model. The third challenge is we don't have an efficient toolkit bridging the science and the public. Under that background, DCC-OCC was endorsed on June 2022, and it is hosted by First Institute of Oceanography, China. In fact, it is one of the 8 DCC-OCC across the globe, and the only one in China. And the mission of DCC-OCC is to understand the ocean climate nexus and to provide knowledge and solution to climate change. And we try to figure out the challenge file of ocean decade, unlock ocean-based solution to the climate change. And the third one is what support the COAST Toolkit development. I list 4 aspects here. The first one is we have a new kind of observation buoy. Just as Miss Qian introduced in her presentation, we have a new generation GNSS drifting buoys. It is a low-cost buoy. And the second one, we have breakthroughs in forecasting theory and technology. We call our new forecast system OceanNAS for short. It's Ocean Climate Early Warning Universal System. I want to say we have three kind of model system under the OceanNAS. The first one is ocean model named FIO-COM. It has two versions. The first one is global version. The spatial resolution is 1/10 degree. And we also have a higher regional version with the spatial resolution is 130 degree. The second system is Typhoon model system. We call it FIO-AOW. It is a regional version covering northeast, northwest Pacific with a resolution of 130 degree. And the last one is a climate model system. We call it FIO-CPS. And it is a global version with 1 degree resolution. Yeah, the most important improvement of the model is about the B-way theory. Just as Ms. Chen introduced it, in fact, B-way, the main outcome of B-way theory is to include surface wave effect to the ocean surface mixing. So this B-wave effect can improve the, for example, the depth of the mixed layer, and the B-wave theory has not only used in FIO, also been widely used by the world-leading model groups. For example, the RV FISM, GFDR MOM, and EU NIMO, and France CROCO. And the simulation experiment in RV FISM shows that the B-wave effect can reduce subsurface spells by 90%. And the B-wave effect of the B-wave can include the TC intensity forecast. As the fingers, the two fingers, the two fingers show in the last 20 years, the forecast error for TC track have been improved largely, but for the TC typhoon intensity have no significant change. But if we include the B-wave in our model, as the finger in the right bottom show, you can find out if we consider B-wave, consider the wave effect, the model error has a larger has been larger reduced. And in the climate model, the SST bells was also improved. It's about 60% reduced. And the third one is we have many years practical service experience. For example, we established the operational forecasting system from 2006, and provided operational service for more than 20 years. And we also have some successful examples using this system. The first one is the seagrass from Yellow Sea, East China, in 2008, near Qingdao. The left finger shows the seagrass across the coast. The right two fingers show the drift pathway of the seagrass, and the Qingdao was marked by the blue characters. And that year, Qingdao will have the Olympic sailing event, but the government found plenty of seagrass gathered along the coast. So our forecast system provide the drift pathway and helps government to clean the seagrass and to make sure the sailing event to held. And the second example is new it's a Redtail aerosol transport simulation. This accident is occurred in Japan in 2011 when the Japanese Fukushima nuclear station have an accident. The Redtail aerosol was released to the atmosphere. And this slide shows the transport transport route, and you can see after about 2 months after the accident, the aerosol spread in the north hemisphere. And the third example is to search and rescue event. The first one is in Thailand in 2018 when a ship had an accident near Puji Island. And if you look the left top finger, you can find the search area we forecast for the government, for the Thailand government. And the different color shows the different the target area for the different day. And at last, all the people was discovered in the target area we provided. And the right finger, the right top finger show the accident occurred in Cambodia in 2022. It's also a ship accident, and we provide the drift trajectory forecast for the local government, and the local government sent us the appreciate center, acknowledgement center, a letter. And the last one is we have many years active international cooperation. The first one is ODC training course. It's ocean dynamic and climate training under the UNESCO IOC, just as introduced by Ms. Qian. And the second one is we host a UN-decade collaborative center, DCC OCC. And the third one is OSF programming. It is a very important support and sponsor of the COAST Toolkit. And the last one is I want to show you how to use COAST Toolkit. I will use to log in the website directly. And could you see my web page? Okay, now I log into the website. Okay. Maybe the internet is not very good. Okay, it's okay. Okay, as you see, this is the interface is of the toolkit, the COAST toolkit. In the top panel, you can find 6 module. This is 6 main module. The first one is Ocean NAS. Ocean NAS including 4 sub-module. You can see it in the bottom panel. The first one is ocean forecasting. The second one, typhoon forecasting. The second one, typhoon forecasting. The third one is climate prediction. And the last one is search and rescue. Okay, I will first show you the ocean forecast. As you see in the left panel, you can find the different parameters for the global ocean forecast. The first one is ocean temperature. The next one is salinity, sea surface height, and ocean current, sea surface wave peak period, and also the ice condition in the Arctic and Antarctic. And in the left bottom, you can find a panel to select different depths. We provide 51 levels for the different parameters. For example, this is salinity distribution. If we try to see the salinity in the deep ocean, for example, if we select the 31 levels, you can see the depth is about 300 meters deep, and the internet is a little slow. And you can find the ocean salinity distribution for that depth, and yeah. And if we click the screen, you can find the salinity for 1 point. You can got the longitude, and the time. And if you want to see time series, you can click here. You can click the sorry, some maybe. Okay, I use this one. Okay, maybe the internet have some problem. Oh, okay. I will use the PowerPoint to show you some function. Yeah, well, you can check 1 point the parameters in 1 point. For example, the salinity, temperature, current, and you also can check regional forecast results. The regional have a much higher resolution. And if you want to check the typhoon forecast, you can use this submodule, and you can find the typhoon trajectory and the precipitation. And if you can check the climate prediction result for the future 1 year, 12 months, including the wind, the surface temperature, and also in the coastal ecosystem health module, you can check the coral reef bleaching condition. And we also provide some information in the integrated coastal zone management. And we also include the ocean literacy module. This is the ocean forecast. And this is typhoon forecast. And you can check the typhoon history in the left bottom panel. And you can choose different time and see the typhoon movement in the climate prediction function. We provide the parameter and the parameter anomaly for the parameter, and we also define some special special factor. For example, the marine heat wave based on the SST anomaly. Okay, I think I have introduced I will finish my presentation. Okay, thank you very much. Thank you, everyone.
Yeah, hello.
Hello, can you hear me? Yeah.
Yes, please. Right. Thank you very much. If you have questions, please can you post them in the chat? Hello, everyone. So thank you, Dr. Zhao, and for the amazing presentation. Those were some cool demonstrations, and I believe that people will follow up, and also when we publish the video on YouTube, a lot of people will find it very fascinating and follow up. If you have any questions for the speakers, please can you put it in the chat. Yeah, but then there is the second poll that I just launched. So how familiar are you with the forecasting systems or climate services related to the ocean? And also, what kind of societal or management challenges do you think could benefit the most from the OSF product? Please, there are 2 questions for you to respond to. Kindly respond to them so we know what you think. Yeah, I'm glad there is someone who answered that he's not familiar at all. So again, a very great learning. Amazing. Please respond to the post. Yeah, we have most people being somewhat familiar with the OSF, the forecasting systems related to the ocean and climate services. That's amazing. Myself, I am also somewhat familiar with this, even though I haven't used them. I mean, knowledge-wise, I know about these, but haven't used them. I do not have the skills. So yeah, for the societal management challenges that could benefit the most from the OSF products, coastal hazard preparedness, amazing. Yeah, I agree. Marine spatial planning, I do agree as well. Climate adaptation and resilience is also important, and then education and awareness. Nobody answered for the fisheries and aquaculture management. That is interesting. I guess we haven't yet fully discovered how best we can use the product for the fisheries and aquaculture. In fact, like the forecasting, I think it was part of the discussions we had recently. One of the discussions we were having about if we could use GIS and this, if we could integrate some of these forecasting systems into aquaculture at all. So for Dr. Zhao and then Sian, that's also something interesting for you to consider or to look at if there's a possibility of applying the OSF program into aquaculture specifically, because it's also a very developing, one of the most developing sectors. So we don't know, maybe you can't really apply it, but it's a very good thing to look at to see if we can apply it to aquaculture. And most of us aquaculture enthusiasts would be very happy. Fisheries and aquaculture enthusiasts will be very happy to know if it's applicable. Thank you very much again. I don't think there are questions. Yeah, but I would end the poll and share the result quickly so everybody just have a look. Most people are somewhat familiar with the forecasting systems, so that's amazing. And then the management challenges, most are saying the coastal hazard preparedness, which I agree, and education and awareness creation. I agree with those as well. Like I said again, the fisheries and aquaculture management, maybe we don't have the enthusiast yet, but it's something for the speakers to consider, the OSF program to consider and to see. I would be very happy to hear any updates or progress on that. Thank you very much again, Dr. Zhao and then Sian. It's amazing. Like I said, those were some really cool demonstrations, and a bit high level for me, but I guess for many people joining us is really interesting for them to learn, and they will follow up on the program. Do you have any questions for the participants maybe? Yeah, since they don't have
Yeah, thank you, Gauri. Thank you for your support for this webinar and also for the ACOP teams. And we have also get some very useful feedback from the audience. I think in the future, we would like to have everyone interested in OSF to continue keeping an eye on us. And also we will try to address more societal needs as you choose today. And yeah, thank you very much.
Sure, thank you too. Yeah, I think more people could have joined, but the time right now, especially for us, the Africa, we usually have for most of our the webinars, we have most people joining from Africa and South America, but then the time right now is not very favorable. So I think another day we can have the webinar. We can have the same webinar, because now for me it's really interesting, and I know a lot of people who really love this. They are into ocean tech and then the GIS and all this cool stuff, who really love this, but the time is not very favorable for them. So next time I guess we have to plan for a better time and then yeah, have many people enjoy this, because I was really enjoying yeah, the cool demonstrations. So thank you again for those who joined. I mean, this is the ECOP webinar series, and then so today we got to learn about the OSF, the ocean, the forecasting program, and then we, I mean, it's contribute to how to bridge the gap between science and the societal needs through public products. And so it's in the chat. The link is in the chat for those who are interested to learn more about the kits and then the program. Please follow the link and learn more. Also, you can follow Dr. Zhao and then Sian to on LinkedIn. I'm sure you are on LinkedIn, right?
Yes, of course.
Oh, sure. So, I mean, you can also follow them on LinkedIn to maybe engage them if you have any questions, anything you would want to engage them on. I am sure they will be very happy to engage with you. And thank you once again. So follow the ECO program and engage with us on the upcoming webinars. Thank you again, and I hope I will see you another time.
Okay, thank you, Gordy. Thank you, everyone.
All right.
Bye-bye.
Have
Bye-bye.
a lovely day.
Thank you, everyone. Have a
Thank
good
you.
day.